Hello everyone, welcome you all to the another video of the data science series. In this video, we will understand about data preparation phase to model the data. So let's start. How to partition the data in Python. Partitioning data typically involves splitting it into subsets such as training, validation, and testing sets, which is essential for machine learning to evaluate and optimize model performance. In Python, you can partition data using libraries like sklearn, pandas, or numpy. Here are some common methods. Using train test split from scikit-learn. Let's understand the code. Train test split is straightforward for creating train test or train validation test splits. First of all, we will have to import pandas library and train test split. Now define the sample dataset which contains feature 1, feature 2 and target. Split the dataset into features X and target Y. X will contain the features and Y will contain the target variables. Now split the data into 80% training and 20% testing sets. Now this will split the data with 80% of training and 20% of testing set. Further, split the training set into 60% training and 20% validation set. Now, verify the result splits. This will help to print the training set which contain X-train shape and Y-train shape. And this will print the validation set. So, let's run this in Google Colab. So, here the code and let's run this. And here it's giving the output training set, validation set and testing set. Let's move further. Now the another method is manually split using NumPy. This approach is useful if you need full control over the indices and randomness. So we will have to import the NumPy. Assume data x and y are already defined. Create indices equals to np.arrange data.shape 0. Create an array of indices. Now np.random shuffle the indices to randomize the data. Now calculate size for each split. So train size equals to int 0.6 into length of indices. This is for 60% for training and this is value size and it is 20% for validation. Now test size equals to length of index minus train size minus val size. So remaining 20% for testing. Now split indices. This will help to split the indices. Let's move further. Partition data into train, validation and test set. So this is for training set and this is for validation set and this is for testing set. Now print the result. Let's run this. Here it is. Let's move further. Now another method is using pandas for random sampling. If you are working with a data frame, you can randomly sample and then split the data. So import pandas SPD. Assume data is a data frame with target column named target. So this is for Preg 0.6 is for randomly select 60% of rows for training sample and random state 42 is for same random split every time you run the code. Okay. Now temp data equals to data dot drop train data dot index. The rows not in train data are saved in temp data. Now well data, this is for validation data. Now separate features and target. So this will help to separate the features and target. This will contain all the columns except target and this will contain only target column. And this is for printing purpose. Let's run this. So this is printing the training data and validation data and the test data. Now, how to balance the training data set in Python? Balancing a training data set is crucial when dealing with imbalanced classes, as it improves model performance and prevents it from being biased towards the majority class. There are several ways to achieve this in Python, particularly using imbalanced learn, pandas, and numpy. Using class weights in model. Some models allow you to assign weights to classes, which gives higher importance to the minority class without changing the dataset size. Here's an example with scikit-learn's random forest classifier. So this is the example for this. Now, data augmentation for image or text. In image or text classification, you can apply augmentation technique to generate new samples for the minority class, such as rotating, flipping, or adding noise in image data sets or changing wording in text data sets. Choosing the right technique. Random oversampling, undersampling. Useful when a straightforward approach is sufficient. Smart. Useful when you need synthetic data in contiguous feature space. Class weight. Suitable when you don't want to alter the dataset but have support in the model. How to build card decision tree using Python. Building a classification and regression tree in Python is straightforward with libraries like scikit-learn. Card decision trees are used for both classification and regression tasks and involves splitting the data set at various points to maximize information gain and minimize mean squared error. Here's a step-by-step guide to build and visualize a card decision tree. First step is to install required libraries, and second step is to build a card decision tree in Python. Step 1: import libraries and load the data. So these are all for importing the libraries, and this will help to load the data. Now split the data into training set, training and test set. So this will split the data into training set. Now initialize and train the cart model. So this is for the initialization purpose. Now regression tree for contiguous target values. Third step is to evaluate the model. Classification model evaluation, and this is for regression model evaluation. Now, visualize the decision tree is the step 4. Visualize a decision tree helps interpret and the splits and decision rules. Here is how to plot it using plot tree from the scikit-learn. So this will help to visualize the tree and fine tuning the cart model. You can adjust parameters like maximum depth limits the depth of the tree, minimum sample split, minimum sample required to split a node, and minimum sample leaf is to minimum sample required at each leaf node. Now, how to build C5.0 decision tree using Python. C5.0 is an advanced decision tree algorithm and an improvement over the older C4.5 algorithm. While scikit-learn includes support for CART, it doesn't directly support C5.0. However, there are a few workarounds you can use in Python. First one is using a Python wrapper for C5.0 with RPY2. Second one is using sklearn with similar hyperparameters. First, simulating C5.0 with scikit-learn decision classifier. C5.0 uses information gain ratio for splitting like C4.5, while scikit-learn decision tree classifier uses Gini impurity or entropy. We can set it to use entropy and tune other parameters to approximate C5.0 behavior. So this is for the import purpose and this is for the load. Now this will split the data and this will initialize classifier with entropy, and this is for predict and evaluate. Now how to build random forest in Python. Building a random forest in Python is straightforward with scikit-learn. A random forest is an ensemble learning method that builds a multiple decision tree during training and combines their output to improve accuracy and reduce overfitting. Here is a step-by-step guide to build and evaluate the random forest model. So this is a code for this. This will import all the libraries, and this is to load the data, and this will split the data, and this will initialize and train the model, and this is for feature importance plot. Let's run this. And here is the output, and this is the graph for it. That's it for today's video. Thank you for watching.